Hello everyone, welcome to my channel SGKM Education. In last session, we have discussed about the spin-only magnetic moment of different type of inorganic oxides and coordination complexes. Today also we shall discuss about spin-only magnetic moments of coordination complexes or coordination compounds. The questions already came in JEE Advanced and Mains level. So first question is the calculated spin-only moment, magnetic moments of these compounds in Bohr magneton respectively. So you have to find out these two complexes for chromium and copper, the spin-only magnetic moment value you have to find out. So let's do it. Before do this question, first you have to notice that which or what kind of ligand is there. Is there strong field ligand or weak field ligand? So for complex 1, CrNH3 6 3 plus NH3 is the strong field ligand. Strong field ligand. And then you have to find out the oxidation state of chromium. So NH3 is basically neutral ligand, neutral ligand. So it becomes zero oxidation state. And if we consider it is X, so X plus 0 equal to plus 3. So X is here plus 3. So chromium in plus 3 oxidation state, because outside of the sphere is, this is cationic complex, because outside of the sphere that is 3 plus. Okay. Now normal electronic configuration of chromium 24, because 24 is the atomic number of chromium, argon 18 electron system, then 3d 4s, so 3d 5 4s1, this is half filled d orbital. For stability it should become half filled, okay, d5 not d 3d4 4s2. In case of copper also we'll find out the same thing. Now in case of chromium plus 3, the electronic configuration becomes 3d 3 only, because 2 electrons will be removed from outermost shell, one from 4s and 2 electrons from 3d orbitals. Now it becomes 3d3. Now if you draw the d orbitals, that is 3d 1 2 3, only 3 electrons are there. Okay, so 3 electrons are there means, first of all, this is strong field ligand. So strong field ligand, what this next strong field ligand means, that is inner orbital complex. Inner orbital complex, it will form inner orbital complex according to VBT, valence bond theory. So already it is 3d3 system, so there is not possibility of pairing of electrons in 3d orbital, because already 2 d orbitals are vacant here. Okay, so next 4s 4p, after 3d what will come, 4s and 4p orbital on 4s and 3 4p orbitals. So starting from this, the compound will form D2sp3 hybridization. D2sp3 hybridization. So no need of pairing of these 3 electrons. So unpaired, number of unpaired electrons still 3 unpaired electrons. So now how to calculate the spin-only magnetic moment, that the formula is mu equal to root over of n into n plus 2 Bohr magneton. So root over of 3 into 3 plus 2 Bohr magneton. So root over of 15, that means almost 4. So you can write 3.9, 2 or 3.9. So there are two options you are getting. in question. Number 1 and number 3 both are having 3.9 in first cases. Okay, so now we have to check the second one. So this is the spin only magnetic moment value of chromium complex. Next, next we will see for copper complex. Okay, so the compound is CuF6 3 minus. So what is fluoride ligand? Fluoride is weak field ligand. Weak field ligand. So it forms for a strong field inner orbital complex, for weak field outer orbital complex. Outer orbital complex. Outer orbital means outer d orbital complex. Okay. So now first you find out the oxygen state of copper. Fluoride is -1 each fluoride. So if we consider it x, so x plus 6 into -1 equal to -3. Now x becomes 6 minus 3, that is plus 3. So copper is also in +3 oxidation state. Okay. Now what is the electronic configuration of copper 29? Argon 3d10 4s1. This is 18 because due to get stability it becomes 3d10 not 3d9 4s2. Okay, just like chromium. So 3d10 is there. Now in case of copper 3 it becomes Ar3d8 because one electron will come out from 4s and two electrons from 3d. So now it becomes 3d8. Now you draw the 3d orbital, 3d 4s 4p. So 1 2 3 4 5 6 7 8. Okay. Now since it is weak field ligand, so outer orbital complex will form. Outer orbital complex means not in 3d orbital. So there is no chance of pairing of these two electrons. Okay. So whatever will come for only outer d orbital, that means out of the 3d orbital. So 4s 4p, then 4d will come. So from starting from 4s, why we are counting 6 boxes? Because 6 fluoride ligands are there. So that's what we have to start from 4s to 6 orbitals. So 1 from s, 3 from p, and 2 from 4d. Okay, that is denoted as a pairing of electrons. So sp3d2. The earlier one was d2sp3 hybridized, and this one is the sp3d2 hybridized. Okay. Now, so there is no need of pairing of electrons also here. So we can write the number of unpaired electrons is 2. So number of unpaired electron is 2 electron. 2 electron. Number of unpaired electron. Okay. So now you calculate the mu value. Mu equal to root over of n into n plus 2. So root over of 2 into 2 plus 2 root 8. That means almost 2.9 or 2.84 Bohr magneton. Okay. So now which one is the correct option? The first one is the correct option. 3.9 and 2.84. Next question. The pair having the same magnetic moment. This question came in JEE Mains 2020. So what you have to calculate? You have to calculate the magnetic moment of the same pair. Okay, same magnetic moment of the pair of these 4 pairs. Okay. So if you find out the number of unpaired electrons same, that means the magnetic moment also same. Okay. So First one is chromium H2O6 2 plus and FeH2O6 2 plus. So H2O is weak field ligand in both cases. Weak field ligand. Okay. Now iron is also in plus 2 oxidation state. Chromium is also in plus 2 oxidation state. So you know for chromium 24 electronic configuration is Ar3d5 4s1. So for chromium 2 plus equal to Ar3d4. So this is D4 system. In case of iron, iron also Fe26 Ar3d8 4s, sorry, 3d26 3d6 4s2. Okay, 3d6 4s2. Now it is also Fe2 plus, so iron argon 3d6 only. Okay, so in both cases, if you draw the 3d orbital 1 2 3 4 unpaired electron 4, because no need of pairing because of weak field ligand. Weak field ligand means outer d orbital complex, so inner d orbital complex will not form, so no need of pairing out of the electrons. Now for 3d6, so here also 4 unpaired electrons and there also 4 unpaired electrons, so these both are same. Okay, so according to first option, the option 1 is correct. Now you have to cross check the other options. If there are any multiple options question, then so next is manganese Cl4 2 minus and FeCN6 4 minus. So Cn is strong field ligand, strong field, and Cl is weak field ligand. Okay, chloride. Now minus 4 and outside is minus 2, so it becomes plus 2. X minus 4 equal to minus 2, so therefore x equal to plus 2. So manganese in plus 2 system. So manganese normal 25 is argon 3d 4s 18 20 25. Now manganese 2 plus is only argon 3d 5. Okay, and in case of iron, iron also minus 6 is into minus 1 minus 6 minus 4, so plus 2 oxygen state. So normal iron is just now we have seen 3d 6 4s2, so Fe2 plus becomes 3d6 only. Okay, 3d6 only. So just write the orbitals 1 2 3 4 5 6, and here 1 2 3 4 5. Now since this is weak field ligand, so weak field ligand will do outer orbital complex. Okay, so no need of pairing, so all the 5 electrons are unpaired, so there are 5 unpaired electrons. But in case of iron cyanide compound complex, since it is strong field ligand, so it will form inner orbital complex. So inner orbital complex means the d electrons will be pairing out. That means it becomes 1 2 3 4 5 6. Okay, so there is no unpaired electron, zero unpaired electron, zero. Okay, you get it. So this option is not correct, that is confirmed. Next, Next is same chromium H2 whole 6 3 plus, already we have covered. Chromium H2 whole 6 3 plus, we got how many unpaired electrons? 4 unpaired electrons. So the second one we will check cobalt NH3 6 3 plus. So NH3 is also strong field ligand like cyanide. Okay, strong field ligand. So it will do also inner orbital complex. So first you have to check the ligand, that is most important. So 0 because it is neutral ligand 0, so it becomes plus 3 because outermost orbital, sorry, outer orbital charge is 3 plus. Okay, outer out of the sphere. Okay, so uh, normal cobalt 27 is argon 18 3d 4s 4s2 3d7. Now cobalt 3 plus means argon 3d6. Okay, argon 3d6. So it is also it will also form inner orbital complex. That means the first you draw the 6 electron 1 2 3 4 5 6 3d6, sorry, 3d6, and after inner orbital complex formation the all the electrons will be paired out. Okay, so 1 2 3 4 5 6, so there is no unpaired electron, 0 unpaired electron. Okay, last options. Last option already we have done FeH2O6 3 plus. It is having 4 unpaired electrons. Now we have to check the cobalt H2O6 2 plus. So cobalt H2O6 2 plus, H2O is weak field, so it is outer orbital, no pairing out. So it is neutral ligand also, so it is 0 charge. Cobalt is 2 plus. So cobalt 27 just now we have seen 3d7 system, and cobalt 2 plus 3d 7 4s2, and cobalt 2 plus means only 3d7. Now you just draw the orbital, 3d orbital, 1 2 3 4 5 6 7, so only 3 unpaired electrons, and in case of iron aqua complex, that is 4 unpaired electrons, so this is not similar. Okay, so first option is the correct option. So these are the question basically is coming in JEE levels and NEET levels related to spin and only magnetic moment. So in next part also we will discuss about 3 4 questions related to spin only magnetic moment. So please do like, subscribe and comments, and please subscribe, because if you subscribe this channel you will get the further updates. Will come out different level or different topics of questions, important questions or topics that will cover the JEE syllabus and NEET syllabus. Okay, so thank you so much. Please subscribe my channel.